Good day, everyone. Welcome back to my YouTube channel. Um, Today we are actually focusing on Euclidean geometry again. The reason we are focusing on Euclidean geometry, by the way, this is grade 10 Euclidean geometry. And the reason why we are actually focusing on Euclidean, as I've mentioned in our previous video, that Euclidean geometry is a problem to most of the learners out there. So I want to try by all means that I make things simpler for you guys. So without waste of time, let's tackle this question. Make sure you have your pen and paper there. Question 7, complete the statement so it is true, right? So they're saying the line drawn from the midpoint of the one side of a triangle parallel to the second side. Now, to continue or to actually complete the statement there, we need to say it bisects the dead side. It bisects the dead side. It bisects the dead side of a triangle, right? So now, let me try and explain this using a diagram. So let's say you have a triangle. Let's say you have a triangle, né? You have a triangle A, B, and C, right? And then there's a line from the midpoint. Line from the midpoint, right? So maybe this is our P. So our midpoint is P, right? So with that being said, we can simply say, since P is our midpoint, then we can say AP is equals to PB, right? And then, according to the statement, same line is also parallel to one side of the triangle, parallel, right? So, okay, let's say this is just Q. Yeah, let's call this Q. Parallel to one side. So, meaning now, if AP is equals to PB, and then PQ parallel to BC, then we can say AQ is also equals to QC, right? And also BC should be twice PQ. I hope we follow that part, right? So when they say it bisects the dead side, meaning now they're saying it cuts the dead sides into two equal halves, right? So the theorem is about that. So now I've tried to unpack the theorem before we even start answering the question based on the theorem. So now let's go back to the question. Now they're saying ACS is a triangle, P is a point on AS, and R is a point on AC, such that PSRQ is a parallelogram. Okay, by seeing this keyword, a parallelogram. Now I'm just thinking of the properties of a parallelogram. Now, let's try and unpack the properties of a parallelogram before we even answer the question. So, okay, I'll just write PAM for parallelogram. The properties of a parallelogram, number 1, opposite sides are equal. Opposite sides are equal and parallel. in length. That's the first thing. Number two, opposite angles are equal. Number three, diagonals bisect each other. Okay, right? So we have three properties of a parallelogram. So how are we going to use these properties? It will depend with our question, right? So now let's start now. Oh, before we start, let's continue. The PQ intersects AC at B such that B is the midpoint of AR. So B is the midpoint of AR. So if B is the midpoint of AR, meaning now AB is equals to BR, because now B is the midpoint of AR. Believe that we understand that part because I've explained this illustration. So now, let's see. Now they're saying QC is joined, and then CR is equals to PS. Okay, C1 is equals to 50. C1 is equals to 50 degrees. Okay, and then BP is 60. So this is 60 millimeters. Now, let's try and answer the question. 7.2.1. 7.2.1. So now we are answering the question using the information, right? Calculate the size of A. Right? Now, because we are given length BP, which means we are simply focusing on lengths, right? We're simply focusing on sides, rather. So I think we will have to take property number one of quadrilaterals, right? What does it say to us? It says opposite sides are equal and parallel in length, meaning now PS is parallel to QR and also equal, right? And then we are not stopping there. QP is also parallel to RS and equal to RS as well. I believe that we're still on the same page, right? Now we can start answering the question now using the properties of a parallelogram. Ne? Now PS, okay, from this statement they're saying CR is equals to PS, meaning now this side is equals to CR, right? But according to the properties of a parallelogram, we know that PS is also equals to QR, which makes QR to be equals to CR. So which means these two are also equal, right? Which also make these two base angles to be equal, right? Now let me try and write it down so that you can understand. Yeah? So we can say CR is equals to PS. The reason we are just given. And then PS is equals to QR. Opposite sides. Opposite sides of a parallelogram are equal. Right? Opposite sides of a parallelogram are equal. And then we can say, therefore, which means CR is equals to QR, right? So if CR is equals to QR, makes the base angles to be equal. So with that being said, we can conclude and say Q1 is equals to C1, which is equals to 50 degrees. On the horizon, angles opposite equal sides. And then, okay, now that we know our base angles are equals to 50 and 50. So you have your 50 there, 50 degrees and 50 degrees. Now I want us to actually consider this triangle. Triangle RCQ. Ne? Triangle RCQ. So meaning now R3 is equals to 50 plus 50. So meaning now R3, okay, meaning now R3, angle R3 is equals to Q1, angle Q1 plus angle C1. Exterior angle of the triangle. We good, ne? But then now we all know that Q1 that's 50 and then 50, and this will give us 100 degrees. So R3 is equals to 100, right? Again, going back to my sketch. So now I have 100, but I know that these two are parallel, right? Then we can simply say R3 is equals to A because of our Z shape, alternate angles, right? So since PS is equals to QR, then we can also conclude and say AS is also parallel to QR, right? If PS is parallel to QR, then we can also say AS is also parallel to QR because it's the same line, right? So since those two lines are parallel, they make R3 to be equals to A, right? So we can say R3, angle R3 is equals to angle A, which is equals to 100 degrees. And the reason, alternate angles are equal because QR is parallel to AS, or we can use PS. You won't be incorrect. So yeah, we got our first question, which is 7.2.1. Now let's move to 7.2.2. Now they're saying determine the length of QP. Okay, now they're looking for the length of QP. So let's go back to our sketch. We're looking for the length of QP, this one, right? But before we even continue, we know very well that BP is 60 millimeters, right? And our B is the midpoint, which means it makes RB to be equals to AB, right? Given that RS is parallel to BP. Okay, which means we can conclude, I will use a different color, then we can conclude to say AP is also equals to PS, as we've concluded earlier on. AP is equals to PS, and also RS is 2 times BP, right? Then we can start answering the question. So how do we use that information? 7.2.2. Already we know that BP is equals to 60 millimeters, right? But now we know that RS is 2 times BP according to the midpoint theorem. RS is equals to 2 times BP, right? So how do we actually answer this question? Where do I start? Okay, I would say AP is equals to PS. And then the reason line from midpoint. Line from midpoint to one side. To one side of the triangle. Okay, to one side of the triangle, right? That's the reason. And then now we can say, therefore, RS is equals to 2 times BP. The reason, midpoint theorem. Midpoint theorem. And then, therefore, RS is equals to 2 times 60, which is equals to 120 millimeters, right? But QP is equals to RS equals to 120 millimeters. The reason, the opposite sides of a palm are equal. So QP is basically equals to 120 millimeters. As I've stated, the properties of a parallelogram, that these sides are parallel and equal, even these ones are parallel and equal. So yeah, that's the end of our video. So guys, I believe that everyone understood the way I've explained this question. I will come with more questions I'll come with more questions based on Euclidean geometry, so that at least we can get you to how to actually answer the topic. So guys, enjoy your day. Thank you for watching my video. Bye.